Okay, so the question I want to tackle in today's video is quite simple actually. What is the area of the largest rectangle that fits within the graph x squared plus y squared equals 25? So before I start, we actually need to figure out what this graph represents. So there's a hint for that in the description. Pause now if you want to figure it out yourself or look at the hint. But I'm just going to go straight ahead and draw it. This is the graph of a circle. In general, a circle looks like x squared plus y squared equals r squared when it's centered at the origin, or 0, 0. So r squared here is equal to 25, which means we have a circle with radius of 5. We end up with the point 5, 5, minus 5, and minus 5. So any point on the circumference is 5 away from 0, 0. Now that we know what the graph looks like, we can have a look at the rectangle that we put inside of it. So, the largest rectangle put inside of a graph is a kind of optimization problem. We need to figure out an extreme most of the time to look at an optimization problem. So it would either be the tallest and thinnest rectangle, the longest and basically the opposite of that rectangle, or in this case, it would be neither of those, because those just approach a line and a line has no area. In this case, it's the complete middle of both of them. We need to look at a square. So, now's the time for the second hint. How would we find the area of this square? Pause now if you need to think about it. The area of this square, we don't know yet. We'd have to figure out the side length. And we don't know the side length either. But what we do know is the length of the diagonal. This is the circle centre. That length is 5 because it's a point on the circumference. That length is 5 because it's a point on the circumference. So we end up with a circle, square, that looks like this. So how do we figure out the area? I'm going to erase the graph because we don't need to look at the graph now. We need to look at the square. How do we figure out the area of this square? We can use Pythagoras. This is a right angle because it's a square. So we can use a right angle triangle, and all the sides in a square are the same. So, x, 10. 2x squared, therefore, is equal to 100, which means x squared is equal to 50, or x is equal to the square root of 50. That actually simplifies to 5 root 2, but it's more helpful if we keep it as this for now. Because, if I clear the entire page, we have a square. Square root of 50 and the square root of 50, well, these are all of its side lengths. The area of a square is just one of its side lengths squared. So it's root 50 times itself, which means we end up with a square with an area of 50, and that is our final answer.